Hello, my name is Roddy Urquhart. I'm Senior Director of Marketing at Codasip, and I'm joined by my co-author, Ganousis, who is Vice President of Sales and Marketing at Metr. Our talk today is about cloud-based verification of open source RISC-V cores using the Metr cloud platform and the Codasip SweRV support package. Verification is absolutely paramount to developing processor IP cores. And we're going to be talking about some of those issues there today. The example we're taking is the Western Digital SweRV cores, and we're going to deal with how these may be deployed and verified. So, what is the opportunity with open source processor cores? Many people I've spoken to would say, well, it's to avoid cost. We all know that commercially licensed processor IP has fees associated with it. However, we also know in life, generally speaking, there's no free lunch. So how is it with open source processor cores? Well, you pay no fee for the RTL, of course, but there can be many hidden costs around the deployment. In particular, you need to be sure that you have an efficient EDA flow set up, and that this matches the needs of implementing your core into a subsystem on your SoC. Unfortunately, you may find additional costs if the quality is not good of the IP. Whereas software based on open source has a very good reputation for quality, probably open source hardware is less mature. And I've heard of stories of companies who've deployed certain open source cores and then spent part of the design cycle debugging them. But for me, the real opportunity around open source is the possibility of customization. We have tended in the past to think of on-chip processors being in certain silos, like MCU, DSP core, GPU, or application processor. Today, these divisions are tending to blur, and there are opportunities for creating domain-specific processors. In other words, you can tune your processor design to meet the specific needs of your SoC. So I see the opportunity here is to add value rather than to avoid cost. Well, to this audience, this slide is probably going to be redundant, but RISC-V gives us an ideal instruction set to be a basis for customization. As we all know, there are base instructions, there are a number of standard extensions, but there is a well-defined process for adding custom instructions. Another benefit of RISC-V is the microarchitecture is not prescribed, giving us freedom to create a microarchitecture that meets our needs. RISC-V has the other benefits that if you have software using the base instruction set, you can run on literally any RISC-V core, meaning that the ecosystem can grow very quickly. But if you add custom instructions, you can be assured of good performance. General purpose processors do not always run certain algorithms well. And for applications such as DSP, cryptography, and machine learning, it's possible to add custom instructions in order to improve performance. So today's example is the family of SweRV cores, which is a modern example of open source RISC-V cores. These cores target high-performance embedded applications. They were developed by Western Digital, and they are open-sourced via CHIPS Alliance. The RTL is provided free of charge, as you'd expect. Before going further, I'd just like to briefly introduce the three cores in the family. The first is the EH1, which is a single-thread superscalar dual-issue core with a 9-stage pipeline, delivering really outstanding integer performance. The second delivers even more performance it not only has dual issue, but also dual hardware threads. And the third member is the more compact EL2, which has a single thread, single issue, and 4-stage pipeline. So if we want to customize an existing core, there are a number of ways in which we could do it. One would be adding custom instructions. This is well supported in the RISC-V concept, and you could optimize your performance to your particular application. You could create your own domain-specific processing. Another way would be to add microarchitectural features, such as additional registers or ports. And you might even try to remove some logic. You may find that you are comfortably able to meet your performance goals, and you may want to rewrite some of the RTL to improve the power and area. But before we go any further, if you are customizing, you are possibly introducing processor bugs, and these can be costly. If you pick up a bug before tape-out, you may require considerable engineering time to debug and fix the problems. This may delay your time to market. If you discover something after tape-out, you've got the additional cost of a respin, and even worse, delays to your time to market. Worst of all is if you discover something in the field. You then face the cost of deploying firmware patches and, in the very worst case, even replacing your integrated circuits. This costs money and also reputational damage. And even if you don't have something as dramatic as we've seen in the microprocessor area with Meltdown and Spectre, be aware that processor bugs can be expensive to deal with. So let's look at the customization risks and how to address them. If you are creating custom instructions, you are creating some danger points. You are extending the instruction set simulator, the RTL, and the compiler. So you're creating a new processor, and this needs absolutely full verification and not some simple increment. So you need to play safe. You need a rigorous approach. You need to be sure that your modified RTL matches your modified instruction accurate golden reference. Now, of course, your verification plan may be incremental over the original one, but you need to be sure that for your customized processor, you have 100% functional coverage, and you need to achieve very high code coverage. You want to be achieving a good 95% and ideally as close to 100% code coverage that you can manage. So there are a number of verification scenarios we can think of. If you've just reduced the logic a bit, you may want to just try running your original test suite on the modified core. Have the RTL changes broken anything? Has the code coverage worsened? However, running the original test suite will not be sufficient if you have added custom instructions, if you've changed the I/O, or if you've added other architectural features. You need to make sure that for any incremental architectural features, you have additional coverage points. You need to be sure that you verify that the new functionality actually works. Also, you need additional tests to achieve your code coverage goals. Adding features will mean that you've got more code to cover, so you'll need additional random tests and probably directed tests to achieve this. Now, if we look at any of these activities, one thing that is in common is that most of them are ideally run as regressions. So let's go back to where we started, which is the idea of open source processor RTL being free of charge. That is a tremendous benefit. But as we noted earlier, there are potentially additional costs involved in deploying it in an SoC. We need, for example, to have an efficient design flow. we need to be supporting the particular EDA tools that you want to use. So Western Digital and Codasip have cooperated on creating the SweRV Core support package. This aims to provide you with everything you need to deploy your RTL in your SoC. So what do you need? Well, before we even think too much about RTL, you definitely need an SDK because you'll need to develop embedded software as well. You will need RTL simulation, you'll need a suitable test bench, and you will need to support the particular simulator you want to use. You may want to do static analysis on your RTL, such as linting. You'll certainly want to synthesize the design with suitable design constraints. And once you've synthesized the design, you want to take the output and check that it is equivalent to the original RTL. And even though this flow is automated, it's not complete without adequate documentation and also access to support. One thing that Codasip has done with the SweRV Core support package is we've abstracted the user away from the particular EDA tools that you are using. So a month ago, we made a significant announcement. We've increased the choice available to our users by adding a capability for cloud-based verification. I'm now going to hand over to Ganousis, who will explain the benefits of cloud-based verification, particularly in the area of running regressions for verifying a processor design.
Thanks, Roddy. My name is Ganousis. I'm with Metrix. We're an EDA in the cloud company. I'm here today to talk about cloud-based verification because this is a really nice solution for RISC-V processor development. As Roddy explained, the benefit of RISC-V is that you can modify these cores, make them special for your hardware, optimized for your software, but with that comes the requirement that you verify the processor core. A lot of people are realizing that's an additional amount of verification they hadn't planned on. They don't have enough licenses, their test jobs are running longer, so queues are getting longer for sim jobs. So they're looking for a way to augment this. The cloud-based verification is the right way to go. Why? Well, number one, it's easy. Okay, you don't have to install any software, any IP, you don't have to get any licenses, maintain this, you have no interaction with your IT department. What Codasip has done that makes them better than the other RISC-V vendors is they've realized that verification is part of the ecosystem. Not only in the ecosystem do you need interface IP and all kinds of debug tools, but you also need that verification integration as well. And the reason is trying to make this easy for their customers. And it's a powerful simulator. This is not stripped down. It's not a limited capacity or anything. It's fully SystemVerilog compliant, UVM compliant, and will have VHDL in fourth quarter of this year. And perhaps most important, it's inexpensive because nobody expected to have to fund the additional verification as well. So by going in the cloud, people have realized about 50% saving over traditional SystemVerilog types verification platforms. No upfront payments required. So this is a SaaS business model that the cloud supports, which is pay as you go. So you're billed only for your actual usage. So what has Metrix done to change this whole process? Well, we built our own simulator. It's a modern simulator. It's about 5 years old now. It's been on the market. It's been in production use. And it's a true cloud simulator. And what that means is it understands the resources available in the cloud, much unlike a on-premises data center where you're limited by the number of licenses, the number of VIP licenses, the number of computers you have. In the cloud, it's unlimited. There's no concept of a simulation license. It's pay for what you use. You sent me a regression test into the cloud, maybe it had 1,000 or 10,000 test cases. A true cloud simulator like Metrix can analyze that, can distribute that into what's called runners. All those simulations run in parallel, bring that back, and then the data is stored in the cloud. So we have customers that are used to having 4, 5, 6-day regression tests, they're actually running in half a day. It's about a 10x improvement in throughput because you can run in parallel. But equally important is in the cloud, there's always a simulator available. You'll never wait in line. There's no concept of a queue. And you need to run this simulator, it's launched, there's resources for you. So if you think about the time that your simulations are sitting in the queue, then running, and then waiting for you to analyze, you're going to find a significant improvement in productivity by having what we call on-demand verification available. In addition, like I said, you're going to save a lot of money. Okay, we don't license the software. You simply pay by the minute for actual use. This is a real game changer in the EDA industry. Nobody else does this but Metrix. But what it allows you to do is not have to put any money up front. There's no purchase. It's simply make your changes to the RTL, regenerate your SDK with the Codasip tools, and start simulating in the cloud with Metrix. As you're doing that, you're simply paying a fee, and it's pennies per minute. We're not talking a lot of money here for simulations. And on top of that, Metrix is half an EDA company and half an IT company. We have to be cloud computing experts. And so we've worked with lots of partners on security. That's very interesting security in the last 3 years. 3 years ago, nobody wanted to even discuss putting their IP in the cloud. Now people want to discuss why it's better than on premises. People like Qualcomm are finding out that, in fact, when you take somebody's IP, let's say you've got some RISC-V processor IP you've got from a vendor, you have to maintain the security of that. And when it's in your data center, it's much more susceptible to being hacked than in a cloud, where that's their business. They are cloud security experts. And perhaps that's why a recent quote, Caltech, Jet Propulsion Labs, NASA, the people putting people on the moon, people sending rockets to Mars, they think it's safer in the cloud. And that comes from real experience. So security is no longer an issue in the cloud. You get a modern simulator and you pay less. So how's this work? Well, this is an overview. And when you're writing RTL, it's basically software development and debug. So we use a DevOps secure methodology where we have continuous integration with the Git Pro Hub, repo hub here. We build a cluster for every customer, and that's part of the security, is that only your organization, and you can actually separate groups within your organization to have their own clusters, but inside that cluster is everything you need to execute your simulation. It's the cloud simulator from Metrix. Avery IP is a good example. You can put any IP up in there. You can add compilers. You can add, if you think of this as a app store over here, you can add other simulators, other debug tools, whatever you need, we build that for you. And then when you submit your test bench and your RTL, that's where our simulate takes that, executes it, and it has an elastic storage. And that's another key part about the cloud. You'll never run out of storage in the cloud. It's as much as you need. Okay, and it expands as you're executing your simulation. Once that's done, then you can view it through an HTML viewer. So you can see waveforms, you can see coverage reports, you have management consoles, so you can see minutes used, you can see quotas, alerts, all kinds of things in this platform overview. So this is the main simulation environment up in the cloud. And your interface to it, as I said, is through a Git repo and through a web browser. So what that gets you in the cloud? Well, number one, it gets you more productivity. You're never waiting on a simulation. You're not running 3, 4, 5, 6 day regression tests. Your engineers have on-demand and fully parallelized execution of their simulations. So they're going to be more productive. Your quality is going to improve because you're going to be able to do more testing. Okay, because you're not waiting on these simulations. Think of the scheduling problem of I need to launch this regression, it's 4 days long versus it's 4 hours long. I gain back 2 or 3 days of work. If there's something wrong in that regression, I have now those days to fix it. So you're able to do more testing in the same amount of time because of the throughput you get in the cloud. You're going to reduce your expenses, typically by 50%. eSilicon has reported when they moved to the cloud last year, their IT costs alone were reduced 20%. You don't have to buy computers. You don't have to buy network equipment. You don't have to buy security software. You don't pay for IT people to babysit your simulation software. This is a complete offload of all that requirements for you to run simulation. And you benefit from the best security available. It's all for free. So what you get with verification in the cloud in a RISC-V and a SweRV support package is basically the ability to do a whole lot more and spend a whole lot less. With that, I'll turn it over. We'll get Roddy back in here and we'll have a question and answer for you. So thanks for your time today. Hope you found it interesting, and you can contact either Roddy or Dan for more information. So